Afternoon, everybody. I'm here to talk about your health. So the human body, right, looks pretty familiar, doesn't it? So what happens if an alien, comes down and takes one of you up to their ship and it looks at you under a microscope, right? They're not going to know the difference between this body and a chair, right? But what are they going to find? Well, what they'll see is about 10 trillion human cells, or 10 trillion cells, and just looking at it, what portion of those cells represent, all these things that we see here? About 80%, 90%? The real answer actually is that it's only about 10%. So the bones, the skin, the muscle, the cartilage, all that make up your body, what you recognize in a mirror, is only 10% of you. The other 90% are actually bacterial cells. So we've got about something on the order of 9 trillion bacterial cells in our body. Now, people didn't know this until just a few years ago. In fact, just the last 2 or 3 years. Before that, the way you looked at what bacteria you had was you take a swab and you culture it in a lab in a petri dish and you see what grew, and then you look at it under a microscope. Now, the problem with that approach is that most bacteria that live in your body don't grow on a petri dish. So they had no idea. But now, just in the last couple of years, we have genetic sequencing that's become much more cheaper. So with gene sequencing, you can actually look at it, and they're finding all kinds of bacteria. People thought there were only a couple of hundred species that live on our body. Now the number is more than 1,000 and counting. So what does this mean? So as far as the alien is concerned, just looking at our body, what they would see actually is a symbiotic organism, which is 10% human cells, and then 90% is a bacterial ecosystem, because there's thousands of species and trillions of cells. So think of the body as a vessel. I think that's probably the best way to look at it, right? We've got all kinds of ships over here. We've got container ships, we've got aircraft carriers, we've got Chinese junks, we've got sailing ships, and that last one over there is actually a broken ship that's flying at the Alang shipyard in India. And I look around the room, I see all kinds of ships. Luckily, nothing that's broken. Now, if we go and look at these, this kind of an ecosystem, can you just raise your hands if you've ever had a course of antibiotics in your life? Gosh, I don't see anybody who hasn't. Right? Now, next time you take a course of broad spectrum antibiotics, just ask yourself what you're doing to this ecosystem. Also ask the doctor, is it really necessary? I'm not going to tell you, don't ever take antibiotics. That's a silly thing, because if there's something seriously wrong, you've got an infection, you've got to do it. But ask your doctor if this is really necessary for you to be taking that course of antibiotics. Now, talking about the body as a vessel, right? What we have to examine is really the heart of a ship. In ancient times, actually even up until just a few years ago, the heart of the ship was actually the pantry, right? Most ships were sailing ships, and people would set off on these long voyages, and the one room that was heavily guarded under lock and key was always the pantry. And if you broke into it, you would be actually sentenced to death by the captain, because people needed rations to survive for long journeys. So in the human body, the pantry is actually your circulatory system, your blood. The whole point of skin, which is the largest organ in your body, is to stop bacteria, the other 90% that live on you, from getting into your bloodstream, right? Because your blood is full of iron, oxygen, rich nutrients, and bacteria love to get in there. And skin is there to stop the bacteria from getting in. Now, if the skin doesn't do its job properly, the second step is your immune system, right? So let's look at what is the picture of health in the human body. On one hand, we've got the immune system. On the other hand, we've got the bacterial ecosystem. There's an iron balance. Now let's take this one at a time. Right, the immune system is essentially like an army. I like to use the example of ancient Rome, right, where it was a massive empire that was spread across Asia, Europe, and North Africa. But the average Roman citizen was not afraid of a foreign invasion. The average Roman citizen was terrified of their own army. And in fact, in ancient Rome, they had a law They had a river called the Rubicon, which was about 200 miles north of Rome. And the Roman army was prohibited on pain of death from crossing the Rubicon. Because the Roman citizens, the last thing they wanted was an army, their own army, at their doorstep, parked outside the gates of Rome. Because if that happened, then whoever was leading the army would essentially become the king. So your immune system is like the Roman army. We have this term crossing the Rubicon, right, which represents a point of no return. It's a good thing. You need it, and when you need it, it's essential. But if left to its own devices, in the absence of a bacterial ecosystem, the immune system becomes very sensitive, and it starts treating all kinds of benign proteins as invaders. So this is essentially the basis of something called the hygiene hypothesis. Right now, we know that in the rich world, there are a lot of autoimmune diseases that are coming out. Asthma, peanut allergies, which is essentially a hyperactive immune system. And all these are attributed to too much hygiene. So when you start treating bacteria as something that has to be eliminated from your body and from your immediate surroundings, then your immune system is like the Roman army with no enemy to fight. They want to then sack the main city, which is Rome itself. Now let's look at bacteria. The reality is that most of the bacteria, if not all, that live on you are actually well adapted to your body. Which sailor wants to sink their own ship? So they live, as far as they're concerned, the body belongs to them. It's their host, and they have a vested interest in keeping it alive. And if you look at the bacteria that live on your skin, they're actually nitrogen processing bacteria that stop pathogens from colonizing you, because every square inch of your skin is completely taken up by bacteria. So anything that comes on, that lands on you, is essentially outcompeted for resources. So they're not allowed to survive. So actually, your skin is not your first line of defense. The bacteria that live on your skin is your first line of defense. Now, there are three things that we need to know about bacteria, which again have just come about in the last couple of years through the research of Bonnie Bassler and others. The first thing is that bacteria replicate at different speeds. Some of them replicate roughly about every 18 minutes, right? It doesn't seem like much. So you take a bacterial cell and it's doubling every 18 minutes. See where you are in about 5 days. It's actually quite a lot. Some are slow-growing bacteria. They replicate only about every 18 hours or so, like the tuberculosis bacteria. The second thing besides replication is a very interesting property called quorum sensing. Essentially, what bacteria are doing is they're sending out a particular messenger chemical, but they also have a receptor that allows them to measure what is the concentration of that chemical that's around them, which gives them a sense of how many of their cousins of the same species of bacteria are there around them, right? Now, here's the interesting thing. When they have something called a quorum, when there's a tipping point, when there is a lot of bacteria of the same species, then they have a third property that they unleash. When they undergo quorum sensing, they start producing some chemical. It can be anything. It can be a vitamin. It can be a toxin. It can be anything. In fact, in modern-day genetic engineering, insulin is made commercially because they've managed to splice the gene of a very common bacteria called E. coli and replace the toxin that it produces with the chemical with insulin. So the point is that most bacteria are completely benign. Occasionally, they can produce a strain that can be harmful to you, in which case the immune system kicks into play. Now, there are 4 key points in preventive health that I want to talk about. And I'm going to take this one at a time because there is no point understanding what is the bacterial ecosystem and who we are without translating it into how we can live a long and healthful life. We're not going to live forever. No one is going to promise you that. But the ideal scenario is that you live to be 90 or 100, and you're extremely healthy until the end stage of life, and then you pass away quietly in your sleep, right? And hopefully these are the 4 things that will enable you to get there. The first thing is sleep. Now with sleep, right, there's so much evidence out there that you need something on the order of 7.5 hours of sleep. There is no compromise in that. You cannot achieve peak health if you're not getting proper sleep. The reason for it is that it's the only thing that can strengthen and regulate your immune system. The second point about sleep is that it's the only period when cell damage that happens due to your daily activities are repaired. And bacteria in your body also sleep. They go through their own sleep cycles. And that's something that scientists are only now starting to look at. The second thing is resting heart rate. And this is also very new research. If you had to pick the single most important marker in good health, something that we can all use, because we're all built differently, right? So it's hard to come up with one good measure of health, and this is as good as it gets. It's your resting heart rate. So wake up in the morning tomorrow, before you get out of bed, take your forefinger and your middle finger and you measure at your neck and see what your resting heart rate is, and you'll get a sense of where you are and where you should be. So what is the bell curve in terms of the human population? If you took the 7 billion people on this planet and you measured their resting heart rate, this is what it would look like. It's a bell curve, and the average is 72. So if you go to a doctor and they see that your resting heart rate is, let's say, less than 90, around 80, they're not going to worry about it. They'll say, yeah, that's pretty close to the average. But who the hell cares about the average, right? On average, 50% of men die between the age of 70 and 80. Right? On average, half of us will get heart disease. A third of us will get diabetes. I don't care about the average. I want to know what is the average resting heart rate of people who are in peak health. And that's where this little red colored in section, which I colored in this morning, comes into play. So what we're finding out is that for people in peak health, the resting heart rate should be closer to 60. So how do you get there? It's very simple. It's interval training, cardio interval training. And the way you do it is, there's different methods, but a simple exercise would be take a jump rope, jump it, 2 minutes, take a 3-minute break, another 2 minutes of jump rope. So you do 2-minute cycles of jump rope for, you only need to do 5 sets. So that would be 10 minutes of jumping rope. And you don't even need to do it every day. You only need to do it about 3 times a week. 10 minutes of jumping rope split into 5 sets 3 times a week will get you somewhere close to 60. Now, what does that mean? If your resting heart rate is around 60, there is a very low likelihood that you will develop diabetes or heart disease, even if you are genetically prone to doing so. And this is quite a profound research that's coming out now, because it gives people a marker. We don't hardly ever measure our resting heart rate unless you're an athlete. And actually, the lower the resting heart rate, beyond a point, it's also damaging. People like Lance Armstrong and Michael Jordan, they have resting heart rates around 35, 34. And that's actually too low. Something around over 45 is actually the ideal. If it's too low, elite athletes don't have a longer lifespan than the rest of us. In fact, they have shorter lifespans. So now the question becomes, what are the, so I've talked about 2 of them. Oh, I've got 4.5 minutes left. The third easiest thing, right? I mean, these 4 I've listed out there. There's lots more, but these are the low-hanging fruit. Oral health, your dental hygiene is extremely important. Now, there's a very simple reason why. If you're not flossing or brushing your teeth on a regular basis, what happens is you end up with a low-grade infection in your gums, gingivitis, right? We talked already about how bacteria love to get at your blood supply. Your gums are the single weakest point in your body where bacteria can get into your bloodstream and can access your bloodstream. And when that happens, there is a low-grade infection and an immune response that's happening, even when you're sleeping, right? Because gingivitis is a 24-hour infection. And when that happens, your cortisol, your stress hormone is high, your cholesterol is high, your bad cholesterol is high, and that has a long-term chronic impact. Any kind of chronic inflammation is bad for health, and oral health is the easiest place that you can fix it. Just go see a dentist at least twice a year. Twice a year is good. And floss and brush your teeth every day. And the last point is the iron balance, which is where we go back to this slide here. Now, this is quite a tricky concept, because we talk about anemia, which is low iron. And about 1.5 billion people in this world suffer from low iron or anemia. And for them, it's quite debilitating, right? Because the lower the energy, lower the iron in your body, the lower your energy level, you have all kinds of other health-related problems. But there is also the other side. There can be something called excess iron or iron overload. And it's not just, there is a medical condition called hemochromatosis, which is extremely high iron. That's a genetic disease. But even simple, abnormally high iron, which is not medically quantifiable as a disease. Now, the interesting thing about this is that typically women of childbearing age generally don't have too much iron because they're menstruating every month and they lose iron. Men don't have that. Men continue to accumulate iron. And what happens is that the results are fairly easy to see. If you look at the statistical data, women tend to get much more immune diseases, endometriosis, rheumatoid arthritis, ulcerative colitis, all kinds of things. And men tend to get more bacterial infections, right? And this is quite striking in how the data plays out if you look at the statistics. So what are the solutions to the iron balance issue? Well, there are some very straightforward and simple solutions. Let's say you have low iron and you're borderline anemic. The vitamin pills with iron don't really work because the iron is not bioavailable. It can't be easily absorbed. So what you can do is very simple. Just go to Mustafa, buy yourself a heavy iron skillet, and cook some tomato sauce and have some pasta with tomato sauce in it twice a week. Right? Because the tomato sauce, which is acidic, leaches a little bit of iron from the skillet into your sauce, and you eat it, and it's bioavailable, and your anemia gets better. Now, what if... Sounds easy, doesn't it? It is. Now, on the other side of the coin, what if you have too much iron, and you're getting bacterial infections? People who get boils or staph blepharitis or any kind of skin infections, that's the first place that staph gets in. Typically, if you measure their iron, it'll be at the higher end of the range in the laboratory. And there's a very simple way of sorting out that problem. Go to the National Blood Clinic on Outram Road and donate a pint of blood. If you're a man, you should do that 4 times a year. They'll take your blood. You're going to save somebody's life, and you won't need antibiotics because you will not get bacterial infections. So that's really the two key parts. I think what's happened with iron balance is, as we get more and more research into this, I think people will realize that this is something that needs to be watched much more closely and carefully than it has been in the past. So that's all I have to say. Thank you very much.